Okay, in 5-5, we're skipping around a little bit in geometry. Today we're going to, in the video, we're going to use inequalities of triangles to find side ranges, as well as learn the triangle inequality theorem. So for triangles, we can actually look at a triangle and we already know how to classify triangles. So when I say classify, that means, is it a scalene, um, isosceles, or equilateral? And based on like a scalene, remember there's no sides that are the same, right? So let's say this side was 4 and this side was 5 and this side was 8. Okay, so based not only on the side lengths, we can know that the angles are going to be different because the sides are different. So if you had an isosceles triangle, for example, let's say 5, 5, and 9, you know that these angles opposite those congruent sides would have to be congruent to each other. So we already figured out how to classify triangles based on that. But today what we're going to do is we're going to also be able to order side lengths and angle measures given just like a little bit of information. So for example, let's say this was A, this vertices was B, and this was C. Since 8 is the longest side, that would mean the opposite angle, B, would have to be the largest angle. And then since AB is the smallest side, that would mean that the side across from it, C, would be the smallest angle. And then you can figure out what the 5 we haven't talked about yet, so that means A would be the middle angle. So that's how we would order those angles. Now we know more about the angles, which ones are the smallest and which ones are the largest. And that's what we're doing in this first 4 questions. So I'll do 1 and 2 for you, but you guys are responsible for finishing number 3 and number 4. Remember, I need to check those, and we're going to put these answers into responders too. So number 1 says order the side lengths in order from largest to smallest to largest. Okay, so we're going from small to large. Okay, and since they give me side lengths, I can infer about the, oh, sorry, they just want the side lengths. Whoa, okay, side lengths. So the longest, or the smallest side would be that 17.2, so side GH is the smallest. FH, or 20.4, is the largest number, so side FH would be the largest side. And then the middle number would be 19.6, so FG is the middle. FG or GF. The order doesn't, of the letters don't really matter. Okay, so based on those side lengths, we can now assess the angle measures and see which angles are the smallest or the largest. So since GH is the smallest side, this one right here, we're going to take the angle across from it. So that's angle F. It has to be the smallest angle. The largest side we said was FH, so that the angle across from that one is G. See how it's across from it? It's not touching it. So angle G is the largest side. Angle, excuse me. And then the angle across from GF is H. So angle H is the middle. So that's how you would answer number 2. You're going to go ahead and try to do number 3 and 4. Okay, so cool thing we just learned is we can now, using side lengths and angle measures, we can tell whether triangles are scalene, isosceles, or equilateral, and we can also order side lengths and angle measures based on from smallest to largest. So that's a pretty cool trick. The second thing we're going to do is applying the triangle inequality theorem. The triangle inequality theorem basically says that in order to decide if 3 lengths can be sides of a triangle, you have to add up the 2 smallest sides, and they have to be greater than, cannot be equal to, they have to be greater than the 3rd side. And I have a funny story to tell you tomorrow in class about the first time I taught geometry. You guys will find it funny. Okay, so this one's pretty straightforward. For example, if I give you side lengths of 7, 10, and 19, whatever, inches, miles, feet, and I wanted you guys to make a triangle, in order to tell if you guys can first even make a triangle, you guys take the 2 smallest sides, so 7 and 10 are the smaller sides, and they have to add up to be bigger than that 3rd side. So 7 plus 10 is 17. That is not bigger than 19. So no matter how hard you tried, you could not make a triangle. So no, this would not make a triangle. You're going to try to do that same thing for 6 and 7. For number 8, it's the same kind of concept, except I'm just making you use some algebra. So you're going to have to first plug in. So if n equals 4, then this side length would be 4 plus 6, that's 10. If you plugged it in here, 4 squared, that's 16, minus 1, so that would be 15. And if you plugged it in here, 3 times n, 3 times 4, that would be 12. So you take the two smallest sides, that would be 10 and 12. You add them up and you see if they're bigger than that third side, 15. So 10 plus 12, is it bigger than the third side? Yes, so this will make a triangle. All right. Okay, so to recap, we just learned that we can order triangle sides and angle measures, and we can also classify triangles. And then given 3 sides, we can also tell whether or not it's actually going to make a triangle. And I have a funny story to tell you. Last thing we're going to really talk about before we move on to some application problems is finding side lengths. So in these questions, it tells you what 2 side lengths of a triangle are, and then it says find the range. So when I say range, that means what are the possible different third side lengths that could make the triangle. Okay, so to do these problems, what you do, again, like I'm telling you that one side length is 8 and another side length is 13, but depending on what this angle is, we could draw a smaller triangle like this, or we can make that angle between these a lot bigger, and we can have a larger triangle. So there's a lot of different ranges of what this third side could be. And to find that, the shortcut that I want you to write down is it's always going to look like this. You're going to add up the 2 sides and put your answer on this side, and you're going to subtract the 2 sides and you're going to put your answer on this side. So let me do the first one for you and then I'll explain. So the 2 sides are 8 and 13. So if I add those up, I get 21. And if I subtract those, I would get 5. So what that means is that third side has to be larger than 5 inches, but smaller than 21 inches. And I'll put it inches there so we know our units. So what that means is if I had 5 inches here, I wouldn't be able to make a triangle, because it has to be bigger than 5, because the 2 smaller sides would be 5 and 8, and that's not larger than the third side, so that's not a possible side length. If I changed it to 6, though, now my 2 smaller sides are 8 and 6, that's 14. That is larger, so it would make a triangle. The same thing goes for the 21. If I tried a 21, my 2 smaller sides would be 8 and 13, and those don't add up to be bigger than 21. But if I changed it to 20, because it's smaller than 21, then 8 and 13 would add up to be greater than. So you're going to try to do number 2 using this same compound inequality. Your answer should look just like this. Okay, if you flip over to the next side of your notes, this is actually the same exact thing we just did, so you don't have to redo that one more time. The last thing I want to do with you guys is just how we can apply the triangle using the triangle inequality theorem. So it says this figure shows the approximate distance between cities in California. What is the range of distances from San Francisco to Oakland? So now, I know nowadays you guys can find this out on your phone, but let's say for some reason you had a friend in Oakland and you had a friend in San Francisco, and you wanted to visit both of them and you weren't sure how far away they were, and I don't know, something happened and there was no cell phone service and there were no maps whatsoever. So you can use what you learned in geometry to figure out the range. Okay, so what you're going to do to visit your 2 friends is you're going to think back, I know that all I have to do is add up these 2 sides. So 51 plus 46. And then I have to subtract those 2 sides, 51 minus 46. It would make sense to have a negative side length, right? So that means that the distance between the 2 friends that you need to visit would be, let's see, 51 minus 46 is 5 miles, I think. And then 51 plus 46 is 97 miles. So your friends are either 5 miles apart or 5.1 miles apart, so it has to be bigger than 5 miles, but less than 97 miles. So you have to travel either 5.1 miles or 96.9 miles to travel between your 2 friends. Yay! And that's how you can use it in the real world. Try to do number 4 and see, and the reflection, and then we'll do this stuff tomorrow in class. All right, yay for the triangle inequality theorem.